Well, hello everybody and welcome back. It is Jeff again with another Fix-It video. This time we have a 49-inch Toshiba TV. It was sold from Facebook Marketplace. I got it for $30 from the person. They said it wouldn't turn on. I was hoping it was going to be something like a fuse. It'd be an easy fix, and hoping it didn't have a broken screen. I think we're okay in the screen department. I don't think the screen is broken, but unfortunately, from a fuse perspective, I don't know if you can see that on the camera. There's when I plugged it in, the red light down there came on, which means that it's not as simple as a fuse because power is getting to the board somewhere. When I turn this thing on, just using the remote, if I turn it on, you will see that it flashes very quickly. That blinking light down there, you can see that it's blinking down there in the corner. It flashed the Toshiba logo, and then it just goes away. I thought that this was just not turning on, so there was nothing on the screen. I messed with it for a while to try to do some power things I read online, unplug it, hold the power button for, a minute while it's unplugged and plug it back in. Did all these troubleshooting tips that I could see, and unfortunately, I don't know if you can see a shadow, the reflection of the screen, the same remote. I have a Toshiba TV behind me, and the same remote apparently turns it on as well, so it just turned on. I was looking at it for a while, and I realized that, somebody said something, it was a Chromecast update. This is a Chromecast TV. You can see on the remote, it's got a little Chromecast symbol down here. It's a Toshiba built-in Chromecast. And they said it's something to do with the Chromecast process and getting stuck in an update. So try to go through Google Home app and look at the Chromecast and see if it's stuck in an update somewhere. I didn't know what was going to happen, so I went to my Home app. It actually found the TV. It linked to the TV, and it said everything was successful. I'm like, okay. There's clearly power coming to this thing. I don't know if you can see it, probably with the reflection, but I started looking at this thing in certain angles from my ceiling light when it would flash on the back. I don't know if I can make it show, but it's actually on, and you can see it at certain angles with the right background reflection that there is a picture here. I actually Chromecasted something to it. Its sound started playing. It works. You can see it on the screen at those certain angles, but obviously not light enough. Something's wrong with the backlight in this. I don't know if it's going to be fixable. The fact that I get a flash initially makes me think that the backlights are okay, because otherwise it wouldn't show me the logo at all, but I don't know enough about these TVs to know. I did find somebody online who had a similar, possibly the same model TV. He didn't actually say the model number in his YouTube video. So he did some troubleshooting steps that I'm going to try to go through now. They looked relatively basic to go through and try to find what the problem was. In his case, it was some resistors on the board. Let's open this thing up and see what we can find. Got nothing to lose, really, at this point. I got $30 to lose, but it's lost as it is now. So I'm going to get this thing set up, turn it around. We'll be working on this couch because it's just too big to be anywhere else, and we'll see if we have to move over to the bench, take some boards out, move to the bench. Let's get this thing started. Okay, I've taken a bunch of screws out of the back of this TV, a little different camera setup here, and got to work around the legs of the tripod now, but I've got the screws out. It's kind of nice because there's all these little arrows that point to the screws, which I thought were going to indicate these are the important screws, but it kind of points to them all, so it doesn't really matter. There was, however, many screws missing. So that means somebody's been in here before. It may or may not be a problem. It depends on the skill set of the person who got in here before. Maybe they opened it up, said, I don't know what I'm doing, and shot it back, and it's just the same. Not as good as if nobody had been in here, but hey, we still got to give this thing a look. I had two notes. There are two different sizes of screws. This is most of them are this little screw. This longer screw, there was only 3 of them. I think there's supposed to be 5 of them at the base, but I will put that on video so I remember for myself. But let me make sure we're focus, because it's going to try to focus in on my head. Let me turn on manual focus, since it is focused on the on this now. And I got this to the point where I could take the back cover off. Ooh, there's a speaker connector in there, and that just clips off the board. And that sounded like one of the screws. However, I did not see it when I did that. I heard it. Putting that to the side somewhere. Oh, it was this piece of plastic of some type that's in there. But, no bother. Clearly this is a different model than the video I had seen, so I can't follow that video to a T. But let's look for anything that would indicate power that is supposed to get to the backlights. Because in this person's video that I saw, what they did was they first checked the... let me get this thing A little more angled here. Maybe zoom in just a little bit. They found the circuit that went to the backlights and found that there were some resistors on that circuit that were out of spec. So they replaced them and everything started working again. Clearly, if we're looking at a different board, oh, here we go. This is the connector actually over here. I'm assuming this is the power board. This connector right here is the one that controls the backlights. It was the 3 red wires on the one side, the 3 white wires on the other side. And unfortunately, it's a completely different layout though, because on his version, there was a row of resistors, surface mount resistors, that were easier to trace, unless they could have been on the back side of this board actually. So that is possible. I'm going to unplug. He also did some things in his video where he had taken the whole front panel off so you could actually see the backlights, and he verified that all the backlights were working by injecting voltage into them. To get to the front of this thing, you have to take off the bezel, unscrew the screen, take the screen out, take the filters out, and that didn't really help him do anything, so I'm trying to avoid that step. So this might not be a workable solution because it might be a completely different problem, but it presented the same, so it's worth taking a look. Let's get that disconnected. Let's for now get this disconnected, and let me just unscrew this board and see if the bottom looks anything like what his did. Board will lift off. Oh yes, here we go. Yes, actually, this is the exact same design as that board that I saw, so it very well might be the same model. What he did first, time to stay away from that really large capacitor down there, is he checked to make sure these were not shorted, and then he went and checked the resistances of this row under them to see if they were causing the problem. So, as soon as I got the board out, let's take it over to the bench and do some measurements and see if this thing is out of spec in any obvious way. Otherwise, it's back to the drawing board. Okay, so I got this thing over on the bench. As you can see, it's right here. There's not really a great way to do this, but this is the area I'm focusing in on, and I'm trying to see if there's a good way to get this thing zoomed in. I can't get it zoomed in on it and actually have a good read, so it's going to be a little fuzzy. My camera's not really meant to do this. I don't have a fancy camera that you might be able to see. I actually took a picture of it with my phone, and I can zoom in on my phone pretty well, so I have the numbers, because I can't read those. My eyes are going. I have the numbers starting from the left. I'm not going to read them all, but this is a 101. There's 2 capacitors, and there's looks like a 2R21? Yeah, 2R21. And then a 3R01, a 3R01, then 2 more 101s in a row. And it just goes on like that. There's some capacitors sprinkled in there. So what I'm going to do is I'm just going to start doing some measurements. For one, first going to check these and see if they're shorted, because that was his initial first steps, because he said that's, I guess this guy's had like 3 sets that had done the same thing, similar if not the same TV, and he found that those were shorting quite a bit. So let's move some of this stuff to the side. Got my meter in beep mode. We'll just kind of go. I mean, these should be together. I would assume these are ground planes. I'm surprised they're not beeping, but maybe they're not supposed to. Not shorted. Not shorted. Not shorted. And just to be sure, turn it around. Not shorted. Not shorted. Not shorted. So that's plus. I know you can't see my meter, but you can hear it when it beeps. When I turn it into resistance mode now, you are not going to be able to hear it. So you're going to have to trust what I say as I'm going through this, and probably just zooming on through. So it also still, it's the same as the continuity mode, I guess. It just also shows resistance, but beeps when it gets something. So that's a 100.4. So I can actually just zoom out a little bit. You guys don't need to see exactly that I'm on the leads, but you can see over there. So this left one is 100.4, which is in spec. The next 2 are caps. This one's shorted. Okay, that is a shorted resistor, which should be a 2R21. All right, future Jeff here. So the 3R01 and the 2R21 are just actually low resistance resistors. It's 3.01 and 2.21 ohm resistors. And my particular meter actually will show continuity mode in anything less than 5 ohms. So that's why you're getting the beep. There's a different mode that you will hear later in the video that I realize you can select to not have the continuity beep and show higher or lower resistances on the screen itself. So that was the confusion there. So those resistors are actually just fine. It was just me not knowing how to use my meter appropriately at the time. 2R, 3R, 3R, and then 2 more 100 ohms. So I'm probably going to get shorts on this one, this one, this one, and then 2 more 100 ohms. 100. 100. Okay. That's not looking too good because then we got those. So at least the 3 or the 600 ohm resistors, which in his particular case those were the problem. Those are measuring fine. So where would we look next? Let me poke and prod around this board for a minute and see if we can find anything that looks off. All right, and I know it looks a lot different that we've jumped to a very far part in the video. It's because basically we left off, I was diagnosing that board to see if there was anything that looked out of the ordinary. I will tell you one of the reasons I couldn't get some of those resistors to show anything was because my multimeter, it's a new one, so I'm not used to using the whole thing, and you have to hit the select button a couple times to get it into the ranges that you're looking for. So it actually wasn't giving me readings at that because it's a low, those resistors are very low resistance. So it was showing them as open instead of giving me, or as a connection, as opposed to giving me an actual ohm reading. I was able to get my meter into the right mode and tested them, and all of the resistors tested as they should, and they all matched each other in that circuit. So I don't think there's anything wrong with that board. So thinking I was going to give up on it, I decided to just take the set apart and look at the lights, because apparently with these sets, which is something I don't quite understand why they would design them like this, but if any single individual LED, and this is the back of the unit right now, I've taken the screen off. If you want a tutorial on how to do that, there's plenty of videos out there on YouTube that show you how to do it. It's a lot of screws and just lifting carefully to get things apart. And basically you took the covers off and took the filters off, and this is what you're left with. And this is the array of LEDs. Now, if I plug this thing in right now, what you'll notice is everything flashes, as we could see through the case. This one LED does not. And that seems to be the culprit. I guess with these sets, if any single one LED fails, the set is dead. You need either new backlights or to buy a new set. I don't have any of these backlights. I'm going to try to take this thing apart a little bit more, take this cover off, get down to the actual LED strip, so I can look at this particular light to see what can be done. I don't want to spend a bunch of money to buy new backlights, because I think you can buy them for somewhere between $60 and $100. I don't even think this TV is worth it. I think this TV went on sale years ago on a Black Friday sale for like $200. I bought it for $30, broken. If I fix it by adding an additional $60 into it, it puts me at $90. It might be worth it, but I don't know. Let's take this thing apart and see. What I'm curious on is the way that these things, I guess, work is they're in sets of, I believe it's in sets of 4. There's 3 LED drivers on this, so it's going to be 4 strips is driven by one of those 3 circuits. 4 strips is driven by another of the 3 circuits, and 4 strips is driven by the other part of the circuit. I guess if there's any difference in the current draw between the LED ranges is when it shuts the backlight off because something is wrong, and obviously something is wrong. We figured that out. I don't know if, is this the beginning of the, I think this is the, yeah, this is the beginning. So this is the bottom of the TV, actually. I'm actually not sure which side is the bottom of the TV right now because of the way I've taken this thing apart. Let's see. Yeah, that's the bottom of the TV because the power cord plugs in this way. So this is the bottom of the TV. So all the wires are coming in from this side of it. If I move this LED up to the top, even though it's still not working, so I might have a dim spot up here, will that now give me the right current draw? Well, probably not, because the rest of them in the line are still lighting up. if I put some type of resistor or diode or something that's going to match the voltage drop across that LED, will that make the line think that it's okay, and therefore it'll keep the backlight on even though this one won't work? Can I just buy a single one of these LEDs for cheaper than buying a whole backlight strip? These are the answers I don't have, or these are the questions I have no answers to. So at this point, I'm just going to continue going through and try to raise this up. Oh yeah, these are all little screws in here. I was gonna just lift this sheet right off, but it is screwed down. So I have a lot of screws to remove so I can get actually to the light strips. So, well, how are you guys bored with that? And I'll just meet you back here. Okay, so slight change of plans. I realized these weren't nearly as expensive as I thought. You can actually get them from the reputable manufacturers. Here are the reputable TV repair people, such as Shop Jimmy, for closer to $60. I think on his website it was $50, but it didn't talk about shipping. His Amazon store had it for $60. I was hoping to look for this particular light strip and just get one, because I would just want to replace the one for a cheaper price, but I ended up finding a USA shipper for 12 of them, which is the exact number in the panel, so I could replace all of them if I want, for $24.92 plus $4.98 shipping coming from the US. So today is May 13th, estimated to be here between the 17th and the 20th, which is good. I could have bought them from China for around the same price, but that was looking at like June 10th, and right now I have this TV in pieces. So it's going to stay like that until I can get this light strip in. But that gives us some time to wait until I get the light strip in, and hopefully that will solve the problem and have this TV fully functional. For those who wanted to see it, this is the LED strip. It's the K490WDR, longer number down there that I was able to find online, as you saw. I pulled it out of the television. I figure we're waiting for a new one to come in. Might as well have some experimentation with this. Looking at it, I couldn't actually tell. I thought these were like really big fancy LEDs, and I was like, I've never seen something like this before. But these actually, this round part is just a cover. I was able to pop the one off of the broken one as well as the one before it, just because I was examining it, trying to see. I was going to see if I could remove the LED itself from the board. It's interesting because there's no real connection pads on the sides that I can connect to. So I'm assuming it's surface mount to the point where the pads are underneath the LED, but I'm not 100% certain. The back of it is just one metal strip. It's actually much thicker than you would think. It feels like a metal strip, but it's not conductive. I mean, it's sort of conductive if you put your multimeter very close together on it. It will actually conduct, but at a distance like this, there's no continuity between there. So I'm not really sure what this is, and it's all one piece. I was trying to see if it could peel back. I don't know how these things are put together. Since this thing's basically already dead, I was going to see if maybe even putting some hot air on the back of this, though I bet this is going to absorb a lot of it. If I can heat this up enough to remove the broken LED and see if I can see traces under there, and just do some experimentation with this thing to see if we can get any use out of it anymore. Like I said, I still wonder if there's a way to put a resistor at a certain resistance into this thing that would allow it to be able to, actually make the strip think it's fine and just work without one of these on. Actually, I should turn this upside down, so I need to try to do the back. So, looking at how this is, it's right here. So just to the right of this, where I got scrape marks on it. That was from me. It didn't come like that. It looked perfect before. I was trying to scrape it with a razor to see what it looked like. So we're just gonna experiment with it now. See it? 8 seconds. Higher gun, do this. Dead. I'll just look at underneath. Oh, got it. Okay, it is off. It is off. Turn this thing off. Okay. Turn the light back on. So as you can see, the LED fell down there. Let's get the tweezers. Who knows what else has been ruined on the board by doing that. But this was the LED. Oops. Yeah, there's the Not focusing very well, but there's a little LED itself. Let me move this strip out of the way for now. Look at the bottom of this thing. I just dropped it. I dropped it and rolled this way. Okay, whatever. I don't really need it. I wanted to look at this strip more. Okay, so now we actually have access to the pads that were underneath of it. So, oh, there we go. You can't see. The pads were underneath it. Let's see if we can get closer there. And they were not accessible to my multimeter. So I'm going to get my multimeter, and I want to test a couple things. Continuity mode here. I'm assuming these planes, yep, those are the same. And then this is across to here. I wonder, I don't have any just white LEDs. All the LED strips I have are LEDs that are red, white, or red, green, blue, and white, but they don't have the dedicated white LED. So that wouldn't be like a drop-in replacement, I wouldn't think. I also wouldn't know how to wire it up. I just wonder if I can put a these are 3.3 volt LEDs from what I understand from doing all the reading. Is each one of these is 3.3 volts. I don't know the current draw of them though, because I couldn't find any information that said current draw on this strip is supposed to be, you know, X or each one of these LEDs. So it's hard to make a voltage calculation to understand what LED I can put in there that would actually work. But I do wonder, I'm just gonna get, this is just for fun at this point. I'll be right back. All right, so I've just set up a little breadboard here with a small white hobby LED that I have just to test what color it is and what voltage it takes. And as you can see, if I connect it to two 1.5 volt batteries, it is a white LED that works off of 3 volts, which means it should work off of the circuit with 3.3 volts in theory. I mean, I hope that's not too much for it. And I can just solder it in here, and I'm very curious what happens. I did take this strip and put it back in the TV and see if anything happened, and the whole subsection of 4 lights that are connected on the same controller did not work when I did that. And I'm assuming it's because there's not a full circuit going through because this is gone, which leads me to believe that LED, yeah, I don't know anything about that LED actually. But the only question I have is I don't know which direction this LED needs to go. If the positive needs to be on the left, or like this side toward the control circuit, or if it needs to be on the other side. I'm not sure about that. I don't. It should be able to, it flows from positive to negative, so it should be flowing from the positive through the positive to the negative. It should work like this. However, I don't know. I'm just gonna not even do anything about these legs. I'm just gonna literally solder it in, see what happens. Like I said, I got a new one on the way. This is for experimentation purposes to see what would happen, because I'm very curious if this would actually get by in a pinch if needed to. All right, let me just make sure I'm not bridged. Turn it up. We are not. I'm gonna go pop this into the TV. This is gonna be interesting. I'm just gonna turn the camera. That's where the TV's at right now, next to me, instead of moving this whole setup up. I'm very curious what this is going to do. My assumption is I'm not going to cause any detrimental damage to anything else. I could be completely wrong in that assumption. Okay, there we go. Interesting. Same thing, except for with this out of circuit, we got nothing. You didn't see that, but these 4 strips right here didn't light up at all. With this back in circuit, this one did not light. I don't know if you can see that on the board. It did not light. It could be because it's backwards. I don't know how it's supposed to be, like I said. So let's just try to reverse it. It's in the other direction. Like... Would you look at that? So though it's not lit up, I don't know how well the camera can actually show this. I'm trying to get it at an angle without having to take it off the stand because I can't really move the stand. With it not lit up, because I don't know if it's just not getting the right voltage or, ooh, it's getting hot. Definitely not meant to be in there. It's probably not going to last very long. But that was enough to tell this backlight, hey, I've got the right circuit going on now. You can go ahead and turn on and stay on. Like I said, I don't know how long this would last because of the fact of this thing it's getting very warm. So this would not be a safe thing to do, but it does make me wonder if, let me turn this thing off. Let's just see if it does that again. That is amazing. So this has proved the fault. I don't know what to do with this information because that is not the correct LED to go in there. But it clearly is about that one LED not working. I don't know. I'm trying to think about this logically. A 3.3 volt resistor, or excuse me, a 3.3 volt LED that's supposedly off of, well, there's 4 strips. I think they're 10 volts each on these 4 strips. Because it's 40 volts that go across one of those rails, and there's 3 of the rails, and each rail consists of 4 strips of LEDs. So I think there's 10 volts that go through each of these. Actually, it doesn't make sense. So 3, 6, 9, 12, 15, 21. 21 plus, you know, halves around there. I'm wondering if I can just put a resistor in there, because all this LED is doing is acting as a resistor right now. I just wouldn't know what resistance value to put in there, and I feel dumb because I want to do the calculation, you know, it's V equals IR, but that calculation wouldn't really work. Let me just take this thing out of circuit again. I want to measure just the resistance of this LED. I mean, maybe that'll just give me the answer I need, and I can pop a resistor in there. That'll be a lot more prone to, oh gosh, to the heat saving. Let's see. What is the resistance across this LED? Uh, 7.8 ohms. So if I were to just get like a 10 ohm resistor, would that solve the same thing and potentially not get hot? And look at that right there. Top of my back is a 10 ohm resistor. Let's try to put a 10 ohm resistor on here. Is 10 ohms really enough? I wish I could pop another one of these resistors off and be able to test. Like, unfortunately, the pads are underneath, so you can't access anything to know what the resistance is. And this probably isn't theoretically the way this is supposed to go anyway. I'm so amazed that that worked. I could probably get a surface mount resistor, but I want to be able to mess with it. Okay. For the sake of better experimentation here, I've taken a wire from each line of where it's supposed to, the LED is supposed to connect, brought it into this breadboard, and I have a 10 ohm, a 100 ohm, and a 10K resistor here. Because I don't trust my thought process in what I'm doing yet. Granted, it's just, like I said, experimentation, because I know I've already got replacement lights on the way. I am going to then look up, after I do this experiment, I'm going to try to see if I can find the right calculations, understand what exact LEDs these might be to know what their voltage drop is supposed to be, what their resistance level is, how the best way to approach this would be. But right now we're hooked up to the 10 ohm, which would be, in my mind, acting just like that LED was, because it was a 7.8. So let's see what happens when I turn this on. Okay, hooking up to the 10 ohm. Seems to be fine, as expected. Question is, how hot is this getting? Very, very, very hot. Okay, turning that off. In order to switch over and test the next one, I just need to move my positive. So it goes over here to this one. So now it's going to be working through the 100 ohm resistor, because obviously the 10 ohm would not have done it. Okay, so 100 did not work. It must be too high. It's making the reading off, and we shouldn't have heat associated with that one. And then just for fun, let's turn it back off and switch it over to the 10K, which obviously should not work at all. I didn't even see that line light up. Hold on. So once more. Oh no, that line did light up, but it was very dim, and I'm betting that's because of the 10 or the 10K resistor that's in there. That did not work. Just going back to the 100 ohm, make sure I had that in there right. I mean, yeah, it was in there. And then just for experiment's sake, let's say I hook this up to it doesn't go to a resistor at all. Oh, that you could see that the lines that were connected to that circuit didn't light at all. I don't know if we'll do it once more, but you'll see these four don't light up at all because the circuit's not complete. So this testing is fine. What if I straight connect them all together? So this would be as if it just had a short between them with no resistance. It's probably going to light up. Nothing's going to get hot, I guess. That also lights up. That would literally just be shorting across that resistor, or that LED. And it still thinks everything is fine. That's interesting to me, because it makes me wonder what was happening. Are they getting any hotter than their neighbors? Could I just get away with bridging it, putting this back together and see what it looks like? It's probably not going to last for very long. But now that's just a straight connection. The resistor's not going to get hot and burn out. The backlight stays on. I'm going to let this sit here just like this for a while and see if it turns off at some point. Granted, this TV might go into a standby mode or something. I have no idea. I bet once you get this together, too, the diffuser layer, it's probably not even going to have that noticeable of a dim spot right here because there's so many LEDs around it that are still going to get that diffusion through the diffuser layer. This will be interesting. Yeah, let me come back and see if this thing turns off on its own. So I'm going to tell you, this thing has been running for over 10 minutes now. I know that's not a very long test. The LEDs in this strip are absolutely no difference in heat compared to the rest of the LEDs that I'm feeling here. So that's good. The wires themselves are not getting warm at all. I understand that this is not the way this is supposed to be done. The fact that it works, I am going to actually solder this strip, just a jumper solder right across that. I'm going to put this TV back together and see what it looks like. I still have the LED strips en route. I might cancel that order. We'll see how it looks. I'll probably not cancel that order and let it come back in. I'm just really curious to see if this is going to work. And I know many of you guys are out there are going to say he doesn't know what he's doing. You are absolutely correct. I have no idea what I'm doing when it comes to something like this. I'm experimenting. This is not a tutorial video. This is only me trying to get this thing working in any way that I can, hopefully as safe as possible. I know it's probably not the same as having an LED in there, but bypassing that LED I feel is going to be safe. I just did some research online, which wasn't specifically talking about backlights, but it was talking about LED strips, and it says, yes, you can absolutely safely bypass an LED and most LED strips if one has burned out. Most places suggest you don't do it, because if one failed, it means others may fail very soon, but bypassing it in the middle of the strip does not seem to be an issue, especially with 3.3 volt LEDs that shouldn't have that much current draw. So I'm going to get the strip sorted and try to put this thing back together. So I bridged the connections in that solder joint like I said I was going to, and the backlight stayed on when I was in my testing phase, and finally the TV is all back together. And I am devastated. As you can see, there's a broken screen. And no, I cannot blame this on the previous owner. You guys all saw the Toshiba logo flash earlier on this thing. This was straight up all me. I was putting the screen back in, and I didn't have it lined up properly with all the bevels when I was putting it back in. And as I screwed something down, it cracked. I was so devastated when that happened. But it is what it is. Now I'm frantically trying to cancel my order for those LED strips because I clearly don't need them at this point, because the screen is no longer functional. But the thing that you can see from this is you have a picture on the screen now. Not really a picture, but you can see that there's colored lines and stuff over here. There's, you know, the different things. The backlight is functional. And even though there's missing one LED, and I think it was probably right about there, it doesn't seem like it would have caused a big problem because of the way the diffuser works. I was so close to getting myself this TV functional, missing one LED in the backlight, that you probably wouldn't have noticed, and I messed it up trying to put it back together. It's so sad, but I needed to finish this video and show you guys that it was on me. It would have worked. I screwed it up myself. And I could have even waited until those LED strips came in and put it in and had to be perfectly functional, but unfortunately, that's not the way that these always go. I did learn a lot about these type of TVs. I've never taken one apart that in depth before. The closest I've come is a previous one I've taken apart and I replaced a fuse and everything started working in there, which is what I was hoping this was. It was an experience. It was fun learning. I wish I hadn't done this and been the one to blame for what we end up with, which is a TV that basically I have to throw in the trash at this point. You could replace the screen itself. I don't know how much they cost. However, this TV is not a smart TV. It's just a standard old TV. It's not a new TV by any means. I think the strips, the backlight strips, were dated from 2015. I don't know if that means that, you know, the TV was from 2015 or, you know, sometime since then, but it's not a new enough TV that I'm that upset about. I spent $30 on this. As long as I can get the refund for those the backlight strips that I tried to buy, I'll be okay. But so close. But anyways, either way, it was a fun video of trying to fix this thing. I understand a lot more about how the backlights work and the things that you can look for. Technically in there, I think the power boards, I looked at that in case I needed to buy a power board if that was the problem. They sell for like $110 themselves. I could theoretically part out this TV for the things that I know that work on it, because obviously the power board works. There's a Wi-Fi board in there. I could probably part this out and make money off of it. I'm not going to go that route. This is probably going to end up in, probably the garbage, unfortunately. Or I might put it up online for free for anybody who wants to like take it and replace the screen themselves. I know a lot more about how they go back together now, too. And unfortunately, I didn't show any of that on camera because I was not trying to do an instructional video on how it works. But here we are. This is the end. The backlight is staying on, which is number one. I would love to get a picture on this thing just to even see how noticeable that one missing LED is, because it might show that it's very easy to like take a backlight if you have one missing LED and just bypass that LED and still have a TV that you barely can notice that issue in. I don't really know because there's not a solid enough picture around the thing to see that specific spot on here. But anyways, this is the end of the video. It's devastating. It's sad. But hey, it's what happens when you try to fix things that you get off of Facebook Marketplace that are not working already. So there you go. Thanks for watching the video, and I'll see you next time.